Hypermetropia. Hi everyone, welcome to the student the brand. So now we are discussing about hypermetropia, myopia. All those completed. So we are going to discuss about electricity chapter. Electricity chapter. Electricity, 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 electricity. Yes, a unit of electric current. Ampere. Ammeter is the device used to measure electric current. Voltmeter is the device we are used to measure. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. Myopia, 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 myopia. Near distance we can see, far distance we can see. Myopia, myopia, myopia. For that correction we are using. Bro. For that correction we are using. Bro, what bro? For that correction we are using. Concave lens, concave lens, concave lens. Hypermetropia, 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 hypermetropia. Far distance, far distance, far distance, far distance we can see, near distance we can see. Hypermetropia, 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 hypermetropia. For the correction, we are using convex lens, convex lens, convex lens, convex lens. Hypermetropia, 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 hypermetropia. that correction, we are using convex lenser, convex lenser, convex lenser, convex lenser, hypermetropia, hypermetropia, convex lenser, convex lenser, hypermetropia, convex lenser, hypermetropia, convex lenser. Okay, so next one we are going to discuss about new Cartesian sign convention, new Cartesian sign convention, all the distance measure from the pole, distance positive along the instant trace, distance negative opposite to instant trace, distance positive along distance positive above the principal axis, distance negative below the principal axis. New Cartesian sign convention, new Cartesian sign convention, all the distance measure from the pole, distance positive along the incident, distance negative opposite to incident, distance positive above the principal axis, distance negative below the principal axis, distance positive along the instant trace, distance negative opposite to instant trace, distance positive above the principal axis, distance negative below the principal axis. Okay, so that's about till now we discussed about myopia, hypermetropia, presbyopia. Okay, so now we'll work out on electricity chapter. Electricity chapter. Okay, so we'll prepare electricity chapter. Along with that, problems will do. Along with electricity chapter, problems also will do. Shall we? Are you ready? Come on, so welcome to the class. So now we are discussing I hope it is visible. Is it clear? Check once. Okay. So I hope it is very clear to you. Right. Okay, come on. Welcome to the Student the Brand channel. Right? So electric current, electric current Electric current is nothing but, so the rate of flow of charge, I equal to Q by T we are considering, I equal to Q by T. So SI unit of charge is Coulomb. So I equal to Q by T, So SI unit of current is ampere, SI unit of charge is Coulomb, SI unit of current is ampere, SI unit of charge is Coulomb. Okay. Just 1 minute. Just 1 minute. Okay, we'll see. So hi, welcome back. So I equal to Q by T. I equal to Q by T we are discussing. So I equal to Q by T. What's the SI unit of current? Ampere. SI unit of current is ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, so I equal to Q by T. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So here SI unit is defined as 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. That is nothing but 1 ampere. Okay, so 1 ampere. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, so now we can take Q equal to inside of the conductor if you are taking. So electrons are flowing. Electrons are charges are flowing. So charges are flowing. Charges will not flow in a single manner. So many will flow. A bunch will flow. So bunch will flow. So like that number of electrons will flow. Number of electrons will flow. That's why it is called quantization of charge. Quantization of charge. That is called quantization of charge. So number of electrons will flow. That's why it is called quantization of charge. Q equal to Ne. Q equal to Ne I am considering. Q equal to Ne. So quantization of charge is nothing but the number of so plus or minus positive plus or minus Ne we are taking because so number of charges, okay, number of charge either positive or negative we are taking either positive. So bunch of electrons, bunch of charges will flow, inside of the conductor. So because of that reason only we can say current is flowing inside of the conductor. So current is flowing inside of the conductor. So current is flowing inside of the conductor. So we can't say only one or two. If it is flowing, current will flow. Current will flow not because of one or two. So we can't see if the current electrons are flowing one or two or charges are moving one or two. So we can't say we can't say current is flowing inside of the conductor. Current is flowing inside of the conductor. Okay, so number of electrons, number of protons, if it is passing in the conductor, if it is flowing in the conductor only, we can able to say current is passing. So that is nothing but integral multiple of charges. So Q equal to plus or minus Ne. Q equal to plus or minus Ne. Q equal to plus or minus Ne. So that is nothing but Q equal to plus or minus Ne. So now we are considering I equal to so Ne by T I am considering I equal to Ne by T and I equal to Ne by T. So here I am considering on one electron how much charge is present. On one electron how much charge is present we will discuss. So I equal to Ne by T. N is the number of charges. So if it is taking positive, so number of charges. If it is taking negative, so only electrons we are considering. So that is nothing but n number of electrons are passing inside of the conductor. That is integral multiple. So number, so many electrons will pass inside of the conductor. Then only we can say current is passing, right? So now you can consider here. So on one electron how much charge is present? On one electron how much charge is present? That we'll discuss. And one electron. So in one electron on one electron, so the charge is present. So on one electron, if you are taking, so if you consider one electron, if you are taking 1.6 into 10 power minus 19 coulomb. So one electron, 1.6 into 10 power minus 19 coulomb. In one coulomb, how many electrons are present? 1 by 1.6 into 10 power minus 19. So in one coulomb, how many electrons are present? So 1 by 1.6 into 10 power 19. 10 power 19 nothing but 1 by 1.6 into 10 by 10. 10 by 10 is nothing but 10 power 19. So here if you consider 10 by 16, okay, so that is nothing but 10 power 19. If you solve this one, you will get 6 point, actually 0. 0.625, 0.625 will get 0.625 into 10 power 19. If you are taking 6.25 into 10 power 18 electrons, so 10 power 18 electrons in 1 coulomb, so this many electrons are present. Very, very important. So on 1 electron, how much charge is present? On 1 electron, how much charge is present? So on 1 electron, so 1.6 into 10 power minus 19 coulomb. On 1 electron, this much charge is present. In 1 coulomb, how many electrons are present? In 1 coulomb, how many electrons are present? 6.25 into 10 power 18 electrons. 6.25 into 10 power 18 electrons. So this many electrons are present in 1 coulomb of charge. So related to this one, we'll do problems. So problems we will ask related to this one. We'll check. So we have to do problems. Okay. Problems, how we are doing, how we are going through it. So we see. So now we'll do so related to this one we'll do problems. So Q equal to NE, right? Related to that one we are doing, right? So yes. And I equal to Q by T also related to that one also. We know this formula, right? So we'll start with I equal to Q by T. So I equal to Q by T will start. So with that I'll explain. So here you can see a circuit of question a circuit of say current of a current a current of a current of 150 milliampere 150 milliampere, so flows through a circuit a circuit for 2 minutes find the find the find the find the amount of charge find the amount of charge that flows through the circuit. So this is the question. So once I try this question, here. They given current is given. Okay, current is given. Just try this question. Current is given. Okay, current is given, and time also given. So find the amount of charge. So current is given, time is given. So they are asking to find out the amount of charge. How to find out the amount of charge? Can you do it once? Try this question. Okay. So how much will get it? Check once, everybody. So here you can see the current of 150 milliampere flows through a circuit for 2 minutes. Find the amount of charge that flows through the circuit. Find the amount of charge that flows through the circuit they are asking. Now you check. Now you see. I 1 ampere equal to. So here this they given. Flows through the circuit 2 minutes. Find the amount of charge that flows through the circuit. Okay, so now given data here given data is, so given data Given data. Current is given. Current is given. How much is given? 150 milliampere. 150 milliampere. Yes. So 18C, 18 coulomb is correct. So very good. So good job. Okay. So 18C. Now you are saying. Okay. So I equal to 150 milliampere. 150 milliampere and the time equal to 2 minutes. 2 minutes. 2 minutes is nothing but. So 1 minute equal to 60 seconds, right? 1 minute equal to 60 seconds. So if you multiply, so 1 minute equal to how many seconds? 60 seconds. 1 minute equal to 60 seconds. So now you multiply, so 2 into 60, how much? 120 seconds. And here, see, normally 1 ampere equal to 1 milliampere equal 10 power minus 3 ampere. 10 power minus 3 ampere. So now you find out I equal to Q by T. I equal to Q by T. So I is given, so 150 into 10 power minus 3 equal to Q by 120 seconds. So Q if you multiply, so here 0 will get. Now how much will get it? You can multiply 150 into 10 power minus 3 into 120. 120. So here into 10 power minus plus 3 into 10 power minus 3. Then Q equal to 18 coulomb. This is the answer. If you multiply once, so if you are multiplying this and this, you'll get 18. So automatically you'll get the answer. Check once. You can multiply, you'll get it. Okay. Yes. Next, we'll go to the next one. We'll go to the next problem. We'll go to the next problem. Okay. So see the next problem. Next problem, going to the next problem. So here question is, next question is, a total of question is a total of a total of 6 into 10 power 46 electrons flow through electrons will flow through. Okay, electrons will flow through a current carrying conductor, a current carrying conductor, when connected through through an electrical circuit, an external power you can take, external connected through an external power supply for 20 seconds 20 second. Okay, so 20 second they given 20 second. 20 second. Find find the value of find the value of value of current value of current value of current in the conductor. Okay, so we have to find out the current. Which formula we can use? Which formula we have to use? Which formula? See, which formula means V equal to, so we can take one more formula. So now you can substitute. So normally, yes, we can use the same formula. I equal to Q by T we can use. But here you can observe here. Okay, so this is the number is given, and electric current is flowing through the connected through electrical compressor. So this they given. Only two values are given. How can we find out? We know the formula. I equal to Q by T. So that is nothing but NE by T. Yes or no? Already see the 1 point. So E equal to 1.6 into 10 power minus 19. That value they didn't give here. But we have to remember that value. So what is that value? 1.6 into 10 power minus 19. They didn't give. Did they give? So one check here. They didn't give that value. They given two values. They given only two values, right? They given only two values. So the next number you have to remember. Okay. So here you see. So N is given 6 into 10 power 46 is given. So the total of 6 into 10 power 46 only given, right? So they didn't give that value, electron value. So we have to remember that value, right? So keep in mind that one. So the value, whatever I'm saying. So this value is very, very important. So one electron equal to 1.6 into 10 power minus 19 coulomb. So this value you have to remember. There is no choice because they didn't give in the exam. They won't give in the exam. That time what you'll do? So if you are not knowing this value, if you are not knowing this value, you do wrong because you'll get tension also. So you'll get a panic. So they didn't give value. How to solve it? Only two values only given. How can we find out? Like that we'll think. So if you remember that value, so we know I equal to NE by T. So now anyway we need to find out the current. N value is 6.6 into 10 power 46 and E value is 1.6 into 10 power minus 19 by T value how much? 20 seconds. That's enough, simple. So if you identify the data, what exactly the data given in the problem, then half of the problem you can solve. So half of the problem is over if you identify the given data. Okay, so what exactly they given. Understood? So that's enough. So I hope it is clear to you all. I equal to 6 into 10 power 46 into 1.6 into 10 power minus 19. So by 20. If you solve it, how much you will get? How much is the answer? Can anybody say answer? What is the answer in this? Answer. What is the answer in this? Answer is we can take so we can check once remaining students whether you are getting this value or not. If you didn't get, you can let me know. So check once whether you are getting this value or not. So 4.8 into 10 power 26. Whether you are getting this value or not, check. So if you're not getting, let me know. Okay. So that's enough. First you have to, in this case, this type of example problems. No, the value is 4.8, right? 4.8 you'll get, not 1.2. Okay. So check once. Only this value you'll get. 4.8 into 10 power 26. Understood? So I hope it is very clear. Just check once. Just 1 minute. So 1 minute. So 1 minute. Just give me 1 minute. Okay. So we'll resume the class after 1 minute. So sorry for the interruption. So you can check once. So, hi everyone. Welcome to the class. Sorry for the interruption. Small interruption. Small break. Okay. Come on, everybody. Welcome to join to the class. Now, here you can observe. Here you can observe in this question as our discussion is going on it. Okay. So the value 1.6 into 10 power minus 19 they won't give. We must find out. Okay, so we have to remember this value, we have to remember that value. So keeping that in mind. Okay, so very important point, very important point. Do you have any doubt on this? So did you get the value answer? So if not, let me know if you didn't get. Okay, come on. Actually, it is a part of my teaching. So I wrote this one. It is a part of my teaching. So student the brand must be special. No? Okay. Name itself, student the brand. So it must be. Yeah, of course. So everyday one design. Everyday one design. Okay, come on. So next we are going to the next one. I hope it is very clear. So next I'll discuss about mm, related to this equal to q by t. This only. So we'll discuss remaining points, electric circuit and electric current related to that one. Problems are there. So continue designers. Okay. So we'll go to the next one. Next one. Electric current completed. So we'll discuss the electrical components. Electrical components. So we'll discuss about electrical components. So we'll see what are the electrical components are there. First one cell. Cell I am taking positive term and negative term as cell. Second one is battery. Second one is battery. Third one is switch. This is the open switch. Open switch. Open switch. Next one, next one is closed switch. Closed switch. Closed switch. Next one, fifth one, open switch, closed switch, resistor, rheostat. Sixth one is rheostat. Either we can take like this or we can consider like this also. Rheostat. Rheostat is the device which regulate the current without changing the voltage source. Which regulate the current without changing the voltage source. So we can take like this also. Rheostat. Rheostat. Here cell, battery, open switch, closed switch, resistor, rheostat. So everyone, hi, welcome to the class. So here you can see cell, battery, open switch, closed switch, resistor, rheostat. Next one, seventh one is ammeter. So eighth one, voltmeter. Ninth one, wire joining. So 10th one, wire crossing. So next one, 11th one, bulb. This is about the bulb. Okay, so this is about electrical appliances, what we are using in electrical circuit. Electrical appliances. Okay, electrical appliances. So cell, battery, open switch, closed switch, resistor. So resistor is a device which is used to oppose the electric current in the circuit. Resistor is a device which is used to oppose the electric current in the circuit. So that is about resistor. SI unit of resistance is ohm. So phenomena of opposing the electric current is resistance. Phenomena of opposing the electric current is resistance. Resistor is a device which is used to oppose the electric current in the circuit. The phenomena of opposing the electric current in the circuit is resistance. Resistor is a device which is used to oppose the electric current in the circuit. SI unit of resistance is ohm. SI unit of resistance is ohm. And yes, next one, ammeter and voltmeter is there. Ammeter. Rheostat is a device which regulate the current without changing the voltage source. So here rheostat is a device which is used to regulate the current without changing the voltage source. That is nothing but rheostat. Coming to the ammeter. Ammeter is a device. So everybody hi. So ammeter is a device which is used to measure the electric current in the circuit. Ammeter is a device which is used to measure the electric current in the circuit. Ammeter is connected in series combination. Coming to the voltmeter. Voltmeter is a device which measures the potential difference. Voltmeter is a device which is used to measure the potential difference. Voltmeter will be connected in parallel combination to the circuit. I hope it is very clear. So these are the electrical appliances. So if it is connected open switch to the circuit, that is open circuit. If it is connected closed switch to the circuit, that is closed circuit, right? Next one, we will discuss now electric circuit related electric circuit will discuss. Electric circuit. So electric current. Now we are discussing one more point. Now you can see electric circuit. A closed and continuous path of an electric current. Electric circuit. Electric circuit. Electric circuit. Electric circuit. A closed and continuous path of an electric current. So a closed and continuous path of an electric current is known as an electric circuit. A closed and continuous a closed and continuous path of an electric current is called electric circuit. A closed and continuous path of an electric current. A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as electric circuit. So I am considering here this is the battery. I am taking. This is the battery switch and ammeter. I am considering. Next one, a bulb. Current is passing like this. So I am taking this the closed surface. So current is passing. Okay. So electric circuit. A closed and continuous path of an electric current. A closed and continuous path of an electric current. A closed and continuous path of an electric current is known as an electric circuit. So if the current is passing from positive terminal to negative terminal, if that see before finding electron proton, so already they given the statement. Scientists were given the statement. The flow of positive charges is considered as a current. The flow of positive charges is considered as a current. But after finding electron, proton, so actually the movement of the electron gives the electric current. The movement of the electrons, the flow of electrons will give the electric current. So instead of changing everything, so better we change the statement conventional current. So we are using that one for our convenience. We are using that statement for our convenience. That's why we are using conventional current. So that's why it is called conventional current. Conventional current is nothing but flow of positive charges direction. Flow of positive charges is known as conventional current. Electric current is nothing but flow of electrons. Here you can understand one thing. Here you have to understand one thing. So charges will move. Positive charges will move from positive terminal to negative terminal. Positive charges will move from positive terminal to negative terminal. Where electrons will move from negative terminal to positive terminal. Positive charges will move from negative terminal to positive terminal. So negative charges, electrons will move from negative terminal to positive terminal. So positive charges will move from positive terminal to negative terminal, whereas negative charges will move from negative terminal to positive terminal. The flow of positive charges is considered as a conventional current. Flow of positive charges is considered as conventional current. Flow of electrons is considered as a electric current. So electrons will move from low potential to high potential. Positive charges has high potential, so negative charges have low potential. Okay, so here positive charges will move from high potential to low potential. Negative charges will move from low potential to high potential. So this is about charges. And next one here, quantization of charge is there. Quantization of charge I already said. So if it is positive will repel, positive negative will attract. Positive will repel, positive negative will attract. Okay, so two dissimilar charges will attract, two similar charges will repel each other. Two dissimilar charges, okay, so two dissimilar charges will repel. Two similar charges will repel. Similar charge, positive. If you are taking positive, positive will repel. Positive will repel. So negative will repel. Negative will repel. So positive negative will attract. Positive, negative will attract. Positive, negative will attract. So negative, positive will attract. So this will attract. This will attract. Okay, so very, very important. Make sure that you are learning. So here we have to understand one thing. We have to understand one thing. Okay. So we have to understand one thing. So positive, positive will repel. Negative, negative will repel. Positive, negative will attract. Negative, positive will attract. So here we can understand one thing. We can understand one thing. We can understand one thing. So two dissimilar charges will attract. Two similar charges will repel. Two dissimilar charges will attract. Two similar charges will repel. Okay. So that is about positive, negative charges. Next one we are going to the potential difference. Okay, so what is the potential difference? Now we can see potential difference. So what is the potential difference? We'll see potential difference. So electric current, electric circuit, electrical appliances. So we discussed all the points. Now we will go to the potential difference. Potential difference. Potential difference. Potential difference. Potential difference is nothing but, so we are within the conductor, if you are considering within the conductor, so the electrons will move from one point to another point. So if you are taking this is point A and point B, I'm taking this is A and this I'm considering B. So positive charge I'm taking, so positive charge. We are doing some work. So positive charge is here. We are doing some work to bring. So work done to bring unit positive charge from point one. So one point to another point. Work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called. Okay. So we are doing some work. So here this is the positive charge. So I'm taking this positive. Okay. So this I'm considering the positive. Okay, so within the conductor, we are doing some work. To bring unit positive charge from one point to another point. We are doing some work to bring unit positive charge from one point to another point within the conductor. Is called potential difference. Work done to bring unit positive charge from one point to another point. Work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So yes, so V equal to W by Q. Okay, so SI unit of potential difference is volt. SI unit of potential difference is volt. Okay, volt. SI unit of charge. SI unit of work is joule. I am taking. SI unit of. So actually, I can write with. I'm writing with the right hand. So I'm trying with the left hand. So we'll see. So SI unit of charge is coulomb. Okay. So this is about coulomb, right? So SI unit of charge. SI unit of volt is SI unit of this one. Okay. So here. So now we are doing some work to bring unit positive charge. We are doing. So this is the positive charge. So from point A to point B. So we are doing some work to bring unit positive charge from one point to another point within the conductor is called. So within the conductor is called potential difference. So V equal to W by Q. SI unit of potential difference is volt. SI unit of work is joule. SI unit of charge is coulomb. So 1 volt equal to 1 joule by 1 coulomb. 1 volt equal to 1 joule by 1 coulomb. So if you are defining 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point, from one point to another point, from one point to another point. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor is called potential difference. So if you are taking a electrical potential, so electrical potential electrical electrical potential electrical electrical potential electrical potential. Okay, electrical potential means, so this is the q, so from infinity, so this is the required field. I am taking required field. Okay, so required field. So we are doing some work, we are doing some work to bring unit positive charge from infinity to the required field, we are doing some work from infinity to the required field. Is called electrical potential. Potential difference is nothing but work done to bring unit positive charge. From one point to another point, within the conductor. Is called potential difference. So 1 volt equal to 1 joule of work is done to bring 1 coulomb of charge from one point to another point. 1 joule of work is done to bring 1 coulomb of charge from one point to another point within the conductor. From one point to another point within the conductor is called potential difference. 1 joule of work is done to bring 1 coulomb of charge. So here we are taking, so we are doing some work, to bring the unit positive charge from infinity to the required field. From infinity to the required field is electrical potential. We are doing some work to bring unit positive charge from one point to another point, one point to another point within the conductor. Within the conductor is potential difference. From infinity to the required field is electrical potential. From infinity to the required field is electrical potential. I hope it is very clear. Next one we are going to the, so related to electrical potential and a potential difference, will do one problem. So related to potential difference, potential difference, related to potential difference, will do one problem. Shall we do it? Okay, come on, ready. So be ready. Come on, be ready. For doing potential difference. Yes. How much work is done? Question is, how much work is done? Question is, how much work is done? How much work is done? Done in moving a charge of 2 coulomb, from a point of 118 volts to a point at 128 volts. Can we do it? So now this is the question. Can you solve it? The question is, so how much work is done in moving a charge? So here charge is given. So charge is 2 coulomb, and so 0.1182 to 128. Okay, potential difference is given. So in this problems we have to find out how much work. So in this question we have to find out We have to find out work we have to find out. What formula we have to use? What formula we have to use? We have to use uh, V equal to W by Q. We have to use V equal to W by Q. That is the formula. V equal to W by Q. We have to use that formula. So that one if you are using. So but here we don't know the V value, but they given so 2. How can we identify? So two different values are given. So final and initial. So we can just subtract it. We can just subtract it, both of it. Okay, so if you are subtracting, then you will get it the value. Check once here, check once here. So I'm subtracting the values. So V2 minus 5, V equal to V2 minus V1, V2 equal to 128, 128, V1 equal to 118, and 10 you will get. So volt, potential difference is 10 volts. Now if you are substituting this value, okay, so V equal to 10 volts. Now Q equal to how much? Q is already given, 2 coulomb. Q equal to 2 coulomb given. So 1 point, another point given. So now we can find out the formula. V equal to W by Q. V equal to W by Q. So V equal to 10. We are W equal to Q equal to C 2. So W equal to 20 joule. Is it clear? So if you are getting different value, you can let me know. If you are getting same value, okay, fine. If you are getting different value, let me know. We can go to the next problem. We can go to the next problem. Is it clear? Is it clear? So everyone, okay. So next one, that is about the related to potential difference. Related to potential difference, one problem. So very, very important problem. Related to potential difference. Check once. So somewhere you did wrong. So multiplication. Next one, we are going to the next problem. So potential difference is completed. Next. Now, so I'll go to one more. Potential difference is completed. Potential difference is completed. Electrical potential. Next one, Ohm's law. Ohm's law. Ohm's law related problems also will do. Ohm's law. So I'm taking the Ohm's law. Ohm's law is nothing but the potential difference across the given metallic conductor. The potential difference across a given metallic conductor is directly proportional to current flowing through it. The potential difference across a given metallic conductor. The potential difference across a given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. So that one we are considering now. So we can see. Okay. So this is the resistor, switch, this ammeter, and 4 cells, 1, 2, 3, 4. Now you can observe in this case. So this is a potential difference. Potential difference. So current is passing. Current is passing. Current is passing. So you can see when the current is passing from here. Okay, so I hope it is very clear. So it's visible, audible, everything. Now you can check. So current is passing. Then we are taking, when we are considering like this, 1.5 volts, 1.5 volts, 1.5 volts, 1.5 volts. So current is passing. So across this one, we are taking positive, negative. We are taking positive, negative. We are considering positive, negative. Right? Yes. Now you can take, now you can consider the potential difference across the metallic conductor. The potential difference across the metallic conductor is directly proportional to current flowing through it. The potential difference across a given metallic conductor, the potential difference across a given metallic conductor, the potential difference across a given metallic conductor is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. V is directly proportional to I, V equal to IR. So now I am considering. So V equal to IR I am taking. V equal to IR. Here Ohm's law gives the definition of resistance. 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 Okay. So now I am considering here V is directly V equal to IR, V is directly proportional, V equal to IR, R equal to V by I, 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 R equal to V by I. The potential difference across the ends of the given metallic conductor. So the potential difference across a given metallic conductor, the potential difference across a given metallic conductor, the potential difference across the ends of the given metallic conductor, the potential difference across the ends of the given metallic conductor is directly proportional to current flowing through it. Is directly proportional to current flowing through it. V is directly proportional to I, V equal to IR. So here I am considering this across this resistor potential difference is there. Across the resistor potential difference is there. Potential difference is there. Okay, so potential difference I am taking now. V is directly proportional to V equal to IR. R is the resistance. R is the resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Ohm's law gives the definition of resistance. Now we can take materials required. What are the materials required? Materials required. Materials required. Okay, materials required to do the activity. So materials required to do the activity. First one, 4 cells. We need 4 cells. So here we are connecting one by one, 1 and 2 and 3 and 4. So we need 4 cells. 4 cells of 1.5 volts each. 4 cells of 1.5 volts each. Okay, so we are considering 4 cells of 1.5 volts each. Second one, nichrome wire. Okay, so 0.5 meters. And third one you can see ammeter. And fourth one voltmeter. And fifth one switch. So this one I am considering K, that is switch. Okay, so next one connecting wires. Sixth one connecting wires. Connecting wires. Procedure. So what is the process? So we will do it. What is the process? Okay, so we have to connect one cell and take the reading of ammeter and voltmeter. So connect one cell first. No reading of ammeter and voltmeter. So now you can see, first connect one cell, and note down the reading of ammeter and voltmeter. One cell, connect one cell. First you have to connect one cell and note down the reading of ammeter and voltmeter. Next connect to two cells, again note down the reading of ammeter and voltmeter. So like this, so you have to mention and in the tabular form, given below. So this is the tabular form. Now you can check. Serial number, so number of cells, ammeter reading, voltmeter reading, V by I value, that is nothing but R. So V by I value is nothing but R. So serial number 1, 2, 3, 4. 1, 2, 3, 4. And here, so here next, so first you have to connect one cell and note down the reading of, connect one cell and note down the reading of ammeter and voltmeter. First you have to connect one cell you have to connect. That is the reason. So you can observe here the dotted lines are represented. Because of that reason only. So you have to connect one cell, and note down the reading of ammeter and voltmeter and connect to two cells. Again note down the reading of ammeter and voltmeter and mention in the tabular form given below. Repeat the process for 3 and 4. So for 3 cells and 4 cells you have to repeat the process. So if you are connecting 2 cells and the third one 3 and 4, you have to take 3 and 4. Okay, so you have to repeat the same process, connect and note down the reading of ammeter and voltmeter. After noting down, so you can draw you can mention in the tabular form. After drawing that one, so you can take you can draw the graph for potential difference and current. So I'm drawing like this. So if you draw the graph for VI graph, V on y axis, I on x axis. So the graph is linear. So VI graph gives the, so it is a linear, okay, straight line passing from origin. So straight line passing from origin, V is directly proportional to I, and that's the reason. So anyway, voltmeter, ammeter, when you are connecting one cell, we are starting with one cell, right? We are connecting. So that's why right from starting, so it is 0. That's the reason it's starting from 0. So initially it is starting from 0, ammeter and voltmeter. And the next one, so the graph gives the linear, so like this. Okay, for ohmic conductors only, the substances. So the substances which obey Ohm's law, the conductors which obey Ohm's law, the substances which obey Ohm's law, the conductors which obey Ohm's law, those are called ohmic conductors. For coming to the non-ohmic conductors, the graph is not straight line, so that is curve. So the graph is curve like this. Okay, so it will be curve when we are considering like this. Okay, so for ohmic conductors, the graph is straight line, linear. For non-ohmic conductors, the graph is curve. I hope it is very clear to you all. So this is about Ohm's law. V is directly proportional to V equal to IR. So we'll do problems based on this. One related to Ohm's law. Okay, related to Ohm's law and everything. So we'll see now. So here we can take nichromere is an alloy of nickel, chromium, manganese and iron metals. Related to Ohm's law, we'll do problems. Now you see. Now we will see now. Okay, the graph is given. We'll do this problem. Shall we? Come on, be ready. So this is the question. First question is find the current, find the potential difference. We have to find the potential difference when current is given 0.5 ampere. Second question is so current we have to find out when potential difference is 0.75 volt. The third one, find out the resistance value. Can you find out? So this is the question. So tabular form is given. Tabular form is given. Okay. So from that we have to find out. We have to find out. From that we have to find out. Okay. So we check once. So this is the question. This is the question given. Find the potential difference when current is 0.5. Find the current when V equal to 0.5 and find out the resistance. Try it once and let me know. So how many members will solve? We will see. So explanation again will start at the rate of at the rate of 457. Hi Shivani, welcome to the class. Okay then, so be ready. So for explanation now, so we can see. Now we can see. Okay, they given these values. They given these values, right? They given these values. So first we have to find out resistance. Take any interval. Take any two interval. Okay, so I'm taking here. So I'm considering here. First to find out. First to find out resistance. First to find out resistance. First point is I'm taking here any two interval. I'm taking this two interval. So R equal to V2 minus, so nothing but V equal to IR, R equal to V by I. V equal to IR, R equal to V by I, right? So V2 minus V1 by I2 minus I1. So V2 equal to how much? So this is the V, 1.5 minus 1.0 by I2 equal to 0.6 minus 0.4. 0.4. So I'm taking these two intervals. These two intervals. So 1.5 minus 1. So 0.4 minus 0.6 minus 0.4. 0.6 minus 0.4. Now you are taking R value. So here 0.5 will get by 0.2. So 10 by 10. Then you will get 5 by 2. That is 2.5. So R equal to 2.5. That is the resistance. Resistance you got it, right? Resistance you got it. Resistance you got it. So next one we have to do it. First point. First question is. So first question. Okay. Come on. Let's do it. So okay, let it be this one normal. Just for finding R. You can take it 3 also, but sequence you have to follow now. We have to find out potential difference. V we have to find out. I given 0.5. So V equal to IR, right? V equal to IR. From this formula, we have to find out I value 0.5. I value 0.5. So question number 1. I value 0.5 into R value. R value how much? 2.5. 2.5. How much you will get? Can anybody say how much? 0.5 into 2.5. How much? How much you got? How much you got? How much you got? Can you tell me? The answer is 1.25. Answer is 1.25. 1.25 volts. Next one, second one. Second question is. Second question. So here we have to find out a current. V equal to IR. From this I equal to V by R. I we have to find out. Potential difference is 0.75 by resistance how much? 2.5. Can you solve it this question? How much you got? Can you tell me? Can you tell me how much you got the answer? So I equal to 0.3 ampere. Is it correct or not? Check once, is it correct or wrong? So those who are getting answer, let me know. So that's enough for today class. I hope it is very clear. Next we'll do resistors are in series, resistors are in parallel, and Factor depends on resistance. So R is directly proportional to L. R is inversely proportional to area. So like that, these questions also will do it. We will do in the next class. So you'll be having 6 p.m. live class and 9 p.m. also live class. 6 p.m. 6 p.m. will work out. We'll see what we can do. And 9 p.m. actually 6 p.m. for grade 11. Grade 11. So problems we are so we are thinking, we are planning to do problems. And coming to 9 p.m. so electricity only, problems and concept will work out. Okay, problems and concept will work out. So join to the live class 6 p.m. and 9 p.m. So this is about Shiva sir. So welcome to the Student the Brand. If you like this video, please do like, share, and subscribe to Student the Brand, and share your friend, ask your friends to join to the class. Thank you so much.